Hello, today I am going to discuss MCQ problems from the chapter Laws of Motion of class 11 physics. So let us now try to understand question number 1. A 0.2 kg object at rest is subjected to a force 0.3 I minus 0.4 J Newton. What is its velocity vector after 6 seconds? 4 options are given to you. Now you have to find the correct answer. Velocity vector can be written as v equal to u plus at, and a can be written as f by m. So velocity vector becomes v equal to u plus f by m into t. So after putting the value, you will get the correct answer A. Now question number 2. A body of mass 5 kg starts from the origin with an initial velocity u equal to 30 I plus 40 j meter per second. If a constant force F equal to minus I plus 5 j Newton acts on the body, the time in which the y component of the velocity becomes 0 is 5 second, 20 second, 40 second, 80 second. So first of all, we will write the y component of the velocity, which is Vy equal to Uy plus Ayt, and Ay is replaced by Fy by m. So velocity vector becomes Uy plus Fy by m into t. Now we have to find the value of Uy, that is y component of the initial velocity, and Fy, that is y component of force. To find the value of Uy, we can use this equation. So here Uy is 40 meter per second and y component of force is minus 5 Newton. So putting the value of Uy, Fy, m, we get the time equal to 40 second. Okay. So here your correct answer is t equal to 40 second, option C. Now come to question number 3. A balloon of mass m is descending at a constant acceleration a. When a mass m is released from this balloon, it starts rising with the same acceleration a. Assuming that its volume does not change, what is the value of m? So here you can go through the figure. The equation of motion while the balloon is descending, we can write mg minus f equal to ma, and while ascending, f minus m into g equal to m minus m into a. M minus m is left over mass. Okay. So after calculating equation 1 and 2, we get m equal to 2a by a plus g into m. So here your correct answer is option B. Question 4. A young man of mass 60 kg stands on the floor of a lift which is accelerating downwards at 1 meter per second square. Then reaction of the floor of the lift on the man is 528 Newton, 540 Newton, 546 Newton, none. So here we can write the equation of motion while the lift is accelerating downwards. So net force in the downward direction is mg minus r equal to ma. So here r equal to m into g minus a. So after putting m, g and a, we get 528 Newton. So the correct answer is A. Question 5. The displacement of a body moving along a straight line is given by s equal to b t to the power n, where b is a constant and t is time. For what value of n the body moves under the action of constant force? Option A 3 by 2, option B 1, option C 2, option D half. So here we have to find the force. First of all, we have to find the force, and force equal to ma. So to find the acceleration, first of all we find velocity, which is given by v equal to ds by dt, and thereafter we differentiate the velocity to find the acceleration. So acceleration equal to dv by dt, which is n into n minus 1 b t to the power n minus 2. Now we can use f equal to ma. Here we put the value of a, and after putting f becomes mn into n minus 1 b t to the power n minus 2. So for f to be constant, n must be equal to 2. So here the correct answer is option C, n equal to 2. Now question number 6. An impulse I given to a body changes its velocity from v1 to v2. The increase in kinetic energy of the body is given by. The four options are given to you, A, B, C and D. You have to find the correct one. So first of all we write impulse equal to change in momentum, that is m into v2 minus v1, or we find m equal to I by v2 minus v1. Okay. Now change in kinetic energy is written as half m v2 square minus v1 square. So here we put the value of m. Okay, m equal to I by v2 minus v1, and after putting m and calculating we get correct answer option B. So option B is the right answer. Now question number 7. In the given arrangement, n number of equal masses are connected by a string of negligible masses. The tension in the string connected to nth mass is. So here you can see mn is the total mass, okay, and the system is moving with acceleration a. Now first of all we write the equation of motion for the body of mass capital M. So downward consider the downward motion of body of mass capital M. We can write mg minus t equal to ma. This is equation 1. And for the whole mass, that is mn, okay, here we can write the equation of motion t equal to mna. From here equation 1 and 2 we find the acceleration which is given by mg by mn plus m. This is the acceleration for nth block also. So now let us suppose that Tn be the tension in the nth block. So the equation of motion for nth block is written as Tn equal to ma, and a is replaced by mg by mn plus m. So finally we get the correct answer as option A. So option A is the right answer. So thank you for watching this video. Do not forget to like, share and subscribe.